All right, today we're going to draw a detailed mechanism for the chlorination of benzene using chlorine and iron 3 chloride. There's 3 steps that I want you to follow when you're doing this, and if you follow these 3 steps, doing the electrophilic aromatic substitution will be relatively straightforward. First, we want to generate the electrophile. Second, we want to react that electrophile with the benzene ring to generate our intermediate. And then third, we want to deprotonate that intermediate to give our final product. So first step, let's react that chlorine with the iron 3 chloride. We're going to take a pair of electrons. It doesn't really matter which one we pick, but we're going to take one of the pairs of electrons on chlorine and draw an arrow to the Lewis acid, iron 3 chloride, and then that is going to generate our electrophile. All right, that electrophile now is going to react with benzene. We'll draw structure of benzene here. I'm going to draw that hydrogen in the interest of keeping track. All right, so here we want to draw an arrow from our electron-rich benzene ring to the electrophile. We're going to draw it, interestingly, to this chlorine that is on the end. So we'll draw an arrow to that chlorine. Since we're making a new bond with that chlorine, we need to break a bond between the 2 chlorines. So we'll draw an arrow from that bond to that middle chlorine that has the positive charge. When we do that, that'll give us FeCl4 minus and our intermediate. So let's start with the intermediate, because that is the thing we're most interested in. All right, so we have a positive charge. It turns out that we can draw multiple resonance structures for this because it's a conjugated system. So we will draw an arrow from this pi bond to here, and that will give us one of our resonance structures. All right, and then we have an additional resonance structure that we can draw simply by taking this pair of electrons and moving it around, and that will move the positive charge out to this carbon. All right, so there are 3 resonance structures that helps to contribute to the overall stability of that carbocation intermediate. Now, we don't want to forget, we also want to draw the FeCl4 minus, and that's simply what was left over of our electrophile when we did this reaction. We are going to use that again in this next step when we deprotonate. So let's deprotonate. So we're going to take this structure and deprotonate it. So we'll use that FeCl4, which I'm going to write as as chlorine and then a bond to FeCl3. Still a negative formal charge on that iron. And so we're now going to deprotonate using this as the base. So we'll draw an arrow from that bond to hydrogen, and so we're going to make a new bond between chlorine and hydrogen, And we're going to take the pair of electrons that's between carbon and hydrogen and complete the aromatic system to generate our product. Our product here is chlorobenzene plus HCl plus FeCl3. You'll notice that our Lewis acid was regenerated, so that means that our Lewis acid, FeCl3, is acting as a catalyst here. Oh, there we go. So FeCl3 is acting as a catalyst. Sorry, I ran out of room there. All right.